Good morning or afternoon, whenever it is that you're watching this. Again, I know I didn't tell y'all yesterday I wasn't going to be here. I thought I was only going to need to miss one class, but turns out I was going to need to miss a little bit more than that. So they said you probably should just go ahead and take the whole day. Anyways, with that being the case, what I want to do is I want to go over a few of these problems from the homework last night and then just jump right in to the Unit 10 review. That should be headed your way at this time. Go ahead and set it off to the side. I'm going to go through a few of these. Hopefully, I can do all of this within the 45 minutes that we have in class. And again, your test will be tomorrow, and I promise you, it won't be that hard. You're going to do just fine on it if you study this review. Okay? So let's start with last night's homework. Remember, what we started was yesterday we said you have to kind of look at these problems and decide, hey, is this arithmetic, is it geometric, or is it neither? So with this one, again, I look at it, I'm like, well, the gap between 1 and 2 is 1, but 2 and 6 is not 1. So the only thing I would even think here is maybe it's geometric. So I check the common ratio. Second term divided by first term, 2 divided by 1 equals 2. Does 2 times 2 equal 6? No, definitely not. So this does not follow a common ratio. So this would be a neither. It won't be an arithmetic. It wouldn't be geometric. It's neither. All right, but if I look at number 2, if you look at it, it's kind of going down. So initially, I think, well, hey, this thing must be arithmetic. So let's see if we can find a common difference. So I take my second term, 26, and I subtract my first term, 31. 26 minus 31 is negative 5. So is that what it's doing every time? Does 26 minus 5 equal 21? Yeah. 21 minus 5, 60? Yes, there it is. It's definitely arithmetic. So I'm going to write the rule for it because it is arithmetic. And again, we wrote those down, those equations down, which they're going to be on your review. They're going to be on your test. But here was the equation. A sub n equals a sub 1, 31, plus n minus 1 times d, negative 5. I'm going to go ahead and distribute that negative 5. So that's negative 5 times n, negative 5n, and negative 5 times negative 1, positive 5. So my equation for this particular arithmetic sequence is negative 5n, and then 31 plus 5 equals positive 36. So negative 5n plus 36. So pretty easy. Once you get that it is arithmetic, you can just roll right into it. And then number 3, again, I hope that you notice how it's going back and forth. Look, it's positive, negative, positive, negative, positive. There is no possible way a arithmetic sequence can do that. So the only thing possible is maybe it's geometric. So I take the second term, negative 648, and I divide it by the first term, 3888. If you type that in your calculator using your alpha y equals number 1, you get negative 1 over 6. So that's what I do. I go, is negative 648 times negative 1 over 6, does that equal positive 108? If you type it in your calculator, it does. 108 times negative 106 equals negative 18. It does. So this one is geometric. So we were supposed to find the geometric equation. So it is a sub n equals a sub 1, 3888, times your common ratio, negative 1 over 6, raised to the n minus 1 power. And there you have it, okay? So we had one neither, we had one arithmetic, we had one geometric. I told you guys yesterday that you would have 2 of each. So I've done one of each. Here's the last 3, 4, 5, and 6. You can check those out. I'll leave those up there for just a couple minutes. And then we'll move along. Number 4 was arithmetic. As you can see, the equation, in fact, you might want to take a quick pick if you didn't get it right, because we are going to move on a little faster than a couple of minutes. Number 5 was definitely geometric. Your common ratio is 2, so you can see your equation there. And then number 6, I tried both. I tried to subtract 1 minus 0 is negative 1. Nope, it's not going down 1. I tried a common ratio. Well, we're not allowed to divide by 0, so that's undefined. So it was neither. Okay? So pretty easy section. Let's move on down. As you can see, number 12 and 13, no reason to spend any time on those. But I do want to do number 10 and 11 with you. So I look at this and I see negative to positive to negative to positive. So once again, the only thing this could be is geometric. It has to be geometric. So I take 2187 and I divide that by negative 6561. And again, feel free to type that in your calculator. You get negative 1/3. So this equation is a sub n equals a sub 1, negative 6561, times your common ratio, negative 1/3, raised to the n minus 1 power. Okay, now remember, this section is all about finding the S sub 9, or the series. So we're adding all of these terms up of the sequence through the 9th term. So we talked about yesterday how this is where we use the big E. So you're going to go type in alpha window. You're going to do number 2, x from the 1st to the 9th term for that sequence, negative 6561. Open up a new parenthesis, do negative 1/3, close that parenthesis, and raise it to the n minus 1. Actually, sorry about that. Not the n minus 1, the x minus 1 power. And then that is all inside the original parentheses. And if I type that in correctly, that will give me my S sub 9, the sum through my 9th term. And the answer here was negative 4,921. So that was pretty easy. Now if you look at number 11, this one's not going back and forth. See, negative, positive, 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 positive. So it's going up is what it's doing. So I don't know, it looks a little tricky because of fractions, but I'm going to start off with, since it is a little tricky, I'm going to start off to see if it has a common difference. One main reason, we just did a geometric one. I'm assuming this one's going to be arithmetic, but I'm going to check it. Second term, 1, minus the first term, negative 3/2. Now I know minus negative is plus, so what we really have here is we have 1 plus 3/2, and that is 5/2. Okay, now I'm going to leave this one as 5/2 because all of these are written as fractions. If these were decimals, I would have changed that to 2.5. You still can, but I like consistency with my answers. So here's my equation. A sub n equals a sub 1, negative 3/2, plus n minus 1 times 5/2. So I distribute. Leave the negative 3/2 alone. 5/2 times n is positive 5/2 n. And 5/2 times negative 1 is negative 5/2. I'm going to go ahead and bring down my variable part, 5/2n. And negative 3/2 minus 5/2 is technically negative 8/2, which is negative 4. There's my equation for this geometric sequence. But remember, we're finding S sub 24. So if I'm finding S sub 24, I'm going to use my big E from my 1st to my 24th term for the equation 5/2x minus 4. And that will allow me to find S sub 24. And that is 654. So there you have those two. Again, that was stuff that we had done in the past. So that wasn't even new. So nothing we've done up to this point was new. Here's the new stuff. I'm going to go on down. Here you can see number 19, and you can be looking at that while I'm doing number 18. See, the football team is running a jackpot in which the prize will start at $2,500 for the first game. So here's what that tells me. That tells me my first term. My first term is 2,500. But then it tells me it will increase 500 each game if there's no winner. So that's telling me it's going up $500. Going up 500 consistently means it's a common difference. And therefore, this thing is arithmetic. So here's my equation. A sub n equals A sub 1, 2,500, plus n minus 1 times my d value, which we just said was 500. So we've got 2,500 plus 500 times n is 500n, and 500 times negative 1 is minus 500. So if I simplify this, here's my equation. 500n plus 2,000. That's the equation that represents this sequence. Now, here's where we get down to the meat of what this question is asking. If there are no winners, find the value of the jackpot at the end of their 16-game season. So it's asking me for what will it be after 6 games. So is that A sub 16 or is that S sub 16? Well, if it's just asking about how much it is after the 6th game, it's A sub 16. So that's what we're going to do. We're simply going to type in 16. 500 times 16 plus 2,000 will find this solution to be, I'm going to flip my page, it'll be $10,000 at the end. Okay, number 19, you can see here, I tried to see if it was maybe arithmetic because I wasn't sure. And the common difference between these two terms was 5562. If I add 5562 to this, it doesn't equal here. So it must have been a common ratio. So I tried it. It was 1.03. When I multiplied by 1.03, sure enough, it was 196,690.8 something. So yes, that matches. So my equation was 185,400 times 1.03 to the n minus 1 power. But once again, look at what this says. Find the approximate value after 30 years. So we're looking specifically at what it will be after 30 years. So that's A sub 30. Number 20, I want to do that one. I'll leave 21 up here. It's already done as well. Here's what this one says. The construction crew is pounding a stake into the ground. On the first strike, so A sub 1, on the first strike, they hit it in there 24 centimeters. 24 centimeters. And then they do 18 the next one. They hit it, that means they hit it 18 further. And then they hit it 13.5 further. So if you look at those, to me, I think you see to go from 24 to 18 is minus 6. Well, if I subtract 6, it's not 13 and a half. That's impossible. So this must be a common ratio. So if I take my second term, that was the second strike, 18, and I divide that by the first term, 24, if I type that into my calculator, I find that to be 0.75. And the reason I did a decimal instead of a fraction is because this right here was a decimal. So I thought, well, let's just roll with what it was. So now that I know A sub 1, 24, and I know my R, 0.75, here's my equation. A sub 1 times 0.75 to the n minus 1 power. So let's see what this question asks. It says, if this pattern continues, find the total distance the stake was driven in after 7 strikes. See, the total distance means if I accumulate every strike, well, guys, that's E. And we're going to do from the first all the way through the 7th strike for this geometric sequence, 24 times 0.75 raised to the x minus 1 power. So you type that in, and it will find what we call S sub 7, the sum through the 7th term. And if you type that in, that equals 83.19 centimeters. Okay? And then as you can see, the one on the bottom, it was arithmetic. You can tell it's going up 0.3. So I wrote the equation there. And then look, it says the total amount of snowfall for the month. So you have to accumulate all of these up, and that equals 145.7. So that was last night's homework assignment. I hope that you did well on it. If you didn't, hopefully you get it now, because we are moving into the review. So you should have this study guide. I want to go pretty fast. I do want to remind you guys that these equations that are here will be given on the test, even though you really don't need this one. You won't really need it on the test because we're going to use summation. So we're really going to stick with these right here. Okay? Those are the ones. All right. So in the past, when I've given this test, this problem right off the bat is missed way more than it needs to be. It wants me to give the first 5 terms of this sequence. And it tells me a sub 1 equals negative 1. And then it gives me the equation. A sub n equals 2 times a sub n minus 1 minus 5. I hope that this right here, I'm going to highlight that. I hope that this stands out at you. A sub n minus 1 is telling me that this problem is a recursive sequence. So remember, to do the first 5 terms, I need the first one, which they tell me it's negative 1. And then it's just going to build based on the equation. Remember, a sub n minus 1 indicates your previous term. So what am I doing to the previous term? Well, I'm multiplying it by 2, and I'm subtracting 5. I'm multiplying by 2 and subtracting 5. So that's what I'm going to do every time. I'm going to multiply by 2 and subtract 5. Well, what is negative 1 times 2? Negative 2 minus 5, negative 7. Okay, multiply that by 2. That's negative 14. Negative 14 minus 5, negative 19. Then you're going to multiply negative 19 by 2. Negative 38 minus 5, negative 43. Then you're going to multiply that by 2. Negative 86 minus 5, negative 91. So that's how you find your first 5 terms of a recursive formula. But then we move right into number 2. And this is not recursive. Look, do you see a sub n minus 1 anywhere? Nope. In the equation, you do have an n squared. So remember, this one is what we have been working with more recently, the ones that we call explicit. Now, I'm not saying you have to know whether this is arithmetic or geometric, which they're not. All I'm saying is, how do you find the first 5 terms? Well, remember what we said. If I want to find the first term, I plug in 1. If I want to find the second term, I plug in 2. I plug in 3 for the third term, 4 for the fourth term, 5 for the fifth term. So that's how I'm going to do this. So what's 1 squared? 1. 1 plus 7, 8. To find the second term, I don't care about 8. I care about 2. 2 squared is 4. 4 plus 7, 11. To find the third term, plug in 3. 3 squared, 9. 9 plus 7, 16. To find the fourth term, 4 squared, 16. Plus 7, 23. To find the fifth term, plug in 5. 5 squared is 25. 25 plus 7, 32. That's how you find all the terms in an explicit formula. So I'm going to put a couple on the test where you have to write these based on not it being arithmetic, not on it being geometric, but just on what you see. So this one, they want me to write an explicit formula. Okay, now look at this thing. Remember, explicit means to have come up with 1/2, I needed to plug in 1. To come up with 1/3, I needed to plug in 2. Plug in 3. Plug in 4. Plug in 5. So we want to write an explicit formula. A sub n equals. Now, let's just think. what do you notice? Every one of them is what kind of number? It's a fraction. So you know your explicit formula has to be a fraction. What else do you notice about the numerator? Every time the numerator is a 1. So I'm going to just write 1. That's got to make sense. Now look at all these. For the first term, my denominator gave me a 2. For the second term, it gave me a 3. For the third term, it gave me a 4. I know you see it. What's happening with every one of these terms? So when I plug in 1, it gets me to 2. What happened? I simply added 1 to that term number, which we represent with n. So the equation, the explicit rule is a sub n equals 1 over n plus 1. Okay, now number 4, you have to think differently. You think differently because it's recursive. Recursive means, what did I do from 3 to get to 8? Well, think about it. It looks like I added 5. Well, is that what happens every time? Am I adding 5? Adding 5? Sure enough, that's what's happening. Every time I'm adding 5. So that is my change that is occurring. So remember how we write our recursive rule. And please remember this, because this is missed very often on the test, and it shouldn't be. 1, you have to tell them their first term. A sub 1 equals 3. Then you can write an equation, a sub n equals, and remember from this very first problem what has to be in a recursive formula? You have to call on the previous term, a sub n minus 1. And then what change was happening every time? It was adding 5. Now, I know when we were doing this lesson, we had some pretty hard ones. I'm not going to put a hard one on the test. They'll be just as simple as this. If you think them through, you shouldn't have any issues. Okay? Now we get into kind of the meat of what we've been doing the last couple of days, where we're talking about arithmetic, geometric, or neither. Then, based on what it is, we're going to tell our common difference or our common ratio in these first 2 problems. So I look at number 5, and I start thinking, okay, what does it look like to me? Does it look like it's going up by the same number, or does it look like I'm multiplying by something? So it goes from 1.5 to 4, and then 4 to 6.5, and then 6.5 to 9. I think probably some of you guys will recognize that it looks like it's changing by the exact same value. So let's just check. Let's see if it has a common difference. So I take the second term, 4, minus the first term, 1.5, and that equals 2.5. Now, is that how this thing's changing? What is 4 plus 2.5? Does it equal 6.5? Absolutely. How about 6.5 plus 2.5? Does it equal 9? For sure. So sure enough, this one is arithmetic. And therefore, it has a common difference of 2.5. You can put D equals if you want. And that's it. That's all it asks you to do in this particular section. All right, so let's keep on moving. Number 6. Now, again, I know these are fractions, but you can't let fractions bother you. So I want you just to take a moment and let's check to see if this has a common difference. Because maybe you have no idea. So you take the second term, 3 over 8, and you subtract the first term, 3 over 4. So if I were to do that, that would end up being negative 3 over 8. So then I would check it. Does that look like it's subtracting 3 over 8 every time? And you go to your calculator and you can try it out. It's definitely not, because 3 over 8 minus 3 over 8 is 0, not 3 over 16. So it's not a common difference. So let's see if it's a common ratio. So you're going to take 3 over 8, and you're going to divide that by 3 over 4. So go check that in your calculator. 3 over 8 divided by 3 over 4 equals 1 over 2, 1/2. So let's check that. If I took 3 over 8 and multiplied it by 1/2, does it equal 3 over 16? Yep. If I took 3 over 16 and multiplied it by 1/2, does it equal 3 over 32? Yep. So sure enough, there is a common ratio, so this is geometric. And that common ratio, R, equals 1/2. And that's it. That's all there is to those two problems. So we keep on cruising. Number 7. They want me to write the formula for the sequence below in simplest form, then find a sub 42. So first of all, I don't know what kind of sequence it is yet. It's either arithmetic or it's geometric. So I'd like you guys to kind of look at them. And if I was there with you, I would talk it through with you and let you choose. But I want you to notice it's going from negative 13 up to negative 7. It's going from negative 7 up to negative 1. It's going from negative 1 up to 5. So I'm going to check because to me it looks like it's going up by the same value. Let's check. Second term, negative 7, minus first term, negative 13. Well, negative 7 and minus the negative turns into plus 13 equals 6. So that's what I check. Does negative 7 plus 6 equal negative 1? Yep. Does negative 1 plus 6 equal 5? Yep. This thing is arithmetic. So let's answer the two questions they ask. 1. Let's write the simplified form of an arithmetic sequence. So a sub n equals a sub 1, the equation's above you, negative 13, plus n minus 1 times d, 6. I'm going to distribute the 6. 6 times positive n, positive 6n, and 6 times negative 1 minus 6. So here's the simplified version. You bring down your variable part, 6n, and then negative 13 minus 6 is negative 19. So my formula is 6n minus 19. So the last thing this thing wants me to do is they want me to find a sub 42. Simply put, we plug 42 directly into this explicit formula and it'll take care of the rest. So 6 times 42 minus 19 in your calculator equals 233. So a sub 42 equals 233. And that's it. That's all there is to number 7. Let's move on to number 8. Again, I want you to notice this. See how it's going positive, negative, positive, negative. Guys, adding or subtracting the same number over and over again cannot do that. So I immediately think this must be geometric. So let's check to see if it has a common ratio. Second term divided by first term. Negative 16 divided by 8 equals negative 2. Is that what's happening? Does negative 16 times negative 2 equal 32? Yep. Does 32 times negative 2 equal negative 64? Absolutely. This is definitely geometric. So this is a really simple formula to write. A sub n equals first term, a sub 1, 8, times r, negative 2, raised to the n minus 1 power. That's it. You cannot simplify it. You cannot do anything to this to write your equation. Now, the last thing it asked me to do is to find a sub 10. So we're simply going to go to our calculator and go 8, open parentheses, negative 2, close parentheses, raised to the 10 minus 1 power, or you could go ahead and simplify that to 9 if you'd like, but your answer is negative 4,096. If you did not get any of those answers, then you need to double check the way you type things in because these are correct. All right, so there you have it. Moving on to the back side, number 9. If the information given below represents an arithmetic sequence, okay, so we know what we're dealing with here. We want to find a sub 1. So these are like those ones that we talked about. I know that I'm going to use my arithmetic sequence. And in here, in this case, we're going to use a sub 14 in place of a sub n. So here's what I'm going to type. I'm going to say a sub 15 equals a sub 1 plus n minus 1. Well, guys, what is n? If I'm plugging a sub 14 in for a sub n, what is n? 14 minus 1 times my common difference, 9. That's how I do this. So 15 equals a sub 1. And then I'm going to go type this in. 14 minus 1 is 13. 13 times 9 equals 117. So I have a sub 1 plus 117. So how am I going to solve for a sub 1? I'm simply going to subtract 117. So 15 minus 117 is negative 102. Your first term in this sequence is negative 102. All right, easy as can be. Look at number 10. If the information given below represents a geometric sequence, find R. So we know here we're using a geometric sequence. And in a sub n's spot, we're using a sub 5. Okay? In a sub n spot, we're using a sub 5. So therefore, here's my equation. A sub n, 4802, a sub 5, equals a sub 1, 2, times your common ratio raised to your 5 minus 1 power. Again, look, here's 5. That's n. We're plugging it into n spot. Now I'm going to do a couple things at the same time. One, to get r alone, don't I need to move 2? So I'm going to divide by 2. So that's 2401 equals r to the 4th power. Now, some of you guys may have forgotten to type this in, so I'm going to go over here and show you real quick. To do the 4th power, we are going to go to our home screen, and you're going to put a 4, then you're going to go to math, and you see right here number 5, it's got this x root of. We're going to do that, and remember how I put the 4 in there? It inserts the 4 right into the root. So 4th root of 2401. So that's exactly how I do this problem. Okay? I had to get r alone, and I do that by getting rid of the 4th power. So I take the 4th root. Well, the 4th root of 2401, like we just got in our calculator, was 7. So r equals 7. And number 10 is done. Okay? Again, you're going to have problems on the test that look so much like these are not even funny. And I expect that you guys can do this. Okay? Now, number 11. Given the sequence below, find S sub 22. So remember, we're going to use the big E. And I'm going to do this from the 1st to the 22nd term for some equation. Well, what equation? Well, that's what we've got to figure out. So, is this thing arithmetic or is it geometric? Well, initially, I look at this thing and I see it going from 6 to 1, from 1 to negative 4, from negative 4 to negative 9. To me, it looks like it's arithmetic. So let's check that. I'm going to take the first term, 1, and subtract the second term, 1, and subtract the first term, 6. 1 minus 6 is negative 5. Does this thing look like it's subtracting 5 every time? Absolutely. 1 minus 5 is negative 4. Negative 4 minus 5 is negative 9. So this thing is definitely arithmetic. So I'm using the equation a sub 1, 6, plus n minus 1 times d, negative 5. I plug that in. We've got 6 that comes on down. Negative 5 times n is negative 5n. And negative 5 times negative 1 is positive 5. So my a sub n is negative 5n. And 6 plus 5 is positive 11. So this is my equation that represents this particular sequence. So I plug it in right here. Negative 5 but I replace that with x plus 11. So go type that in your calculator, and sure enough, it finds s sub 22, and s sub 22 is negative 1023. Okay? Moving on to number 12. Again, I have to find s sub 9. So once again, just like that last problem, I know for sure I need to do summation, and I need to do it from the first term to the 9th term for whatever the sequence is. So that's my next job. Let's figure out the sequence. Well, notice, guys, it's going from positive 800 to negative 200 to positive 50 to negative 25. We talked about that. The only thing that allows me to do that is a geometric sequence. So I'm going to get my common ratio by taking my second term, that's negative 200, and dividing it by my first term, that's 800. So if you go type that in, and notice how this is a fraction, so I'm going to use my fraction key, and I'm going to do negative 200 over 800. So that's negative 1/4. I'm going to use the fraction because there's answers that were already given to us that are in fraction form. You don't have to do that, but I'm going to, okay? You could also use negative 0.25. So I'm ready to write my equation. Since this is geometric, I use a sub 1, 800, times r, negative 1/4, or negative 0.25, raised to the n minus 1. And that is exactly what I'm plugging in right here. So go type that in for me. I'm not going to tell you tomorrow where to type these in. Alpha window number 2. So that will find s sub 9. And I'm good with a couple of answers. I think I wrote, well, let me just type it in again. I've forgotten. I thought I had it written down, but I didn't. So alpha window number 2, x from the first to the 9th term for the equation 800. Remember, we're going to open up a new parenthesis and do negative 1/4. We're going to close that parenthesis. Don't go outside of that parenthesis. We're going to close that parenthesis and raise it to the x minus 1 power, which equals, and I got 640 point, I mean, that's pretty close. Let's just do 640. That doesn't round very far. So 640 is a good answer here for number 12. All right, moving along. These two, the key here to number 13 is please put all of this inside parentheses, the original ones. So you're going to go alpha window number 2. You're going to define your variable. This one wants you to do from the second to the 9th term. And you're fitting all of this inside this box here. So you're going to go negative 2 times, open parenthesis, 2 alpha y equals number 1 over 3. You're going to close that parenthesis. Don't go outside once again. And you're going to raise that to the x minus 1 power. So you get a weird answer. So I would have taken negative 25220 over 6561, or I would also be okay if you went alpha y equals number 4 and changed it to a decimal and put negative 3.84. So I would have been okay with either of these two. All right. Now, number 14 says expand it. And I'm going to give you 100% credit if you just type it into your calculator. But on the test, I'll give you a couple of bonus points if you expand it. So expanding it is bonus. It's really simple. Hopefully you'll remember. If not, type it in, get your 100% correct. If not, here's what expanding it means. To do the sum from the second to the 5th term for the sequence 3n, it means you've got to do 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. See, from the second to the 5th term, we plug in all of those into the sequence. And then, of course, you can just add those all up. It equals 42. So if you just say, man, that's too long to write, I'm just going to write 42, you'll get 100% correct. But if you expand it, I'll give you some bonus points. Okay, last two. I got about 5 more minutes. Let me go fast. Bricks are stacked in a pile with 42 bricks on the bottom. So down here on the bottom, which I'm going to call A sub 1, we got 42 bricks. And 9 bricks on the top row. That means top row. Sorry, I don't know what happened there. Each row has 3 fewer bricks than the row below it. Write a formula to represent the number of brick on each row, then determine the number of bricks on the 7th row. Now this 9 bricks, I think, kind of threw you off a little bit. Here's why. It tells me each row has 3 fewer bricks, so that's telling me that my common difference is minus 3. Okay, it's telling me that my common difference is minus 3 if A sub 1 is 42. Okay, if you started with the top row, 9, it would be a positive 3, so be careful with that. Now, let's go ahead and figure out our answer. And again, this one, you don't really have to write the equation. They want to know how many bricks are on the 7th row. They want to know A sub 7. And here's our equation. It's A sub 1 plus n, well, n is 7 in this case, minus 1 times negative 3. Okay, so I don't really even have to simplify this. I can just plug in the one they need and find the 7th row. So it's 42 plus n minus, or 7 minus 1, which is 6 times negative 3. So that's 42, and then 6 times negative 3 is negative 18. So 42 minus 18 is 24. Okay? So A sub 7 has 24 bricks on it. Okay? So that one's pretty easy. Last one, number 16. The table shows the number of seats in the first 3 rows of the concert hall. This pattern continues for a total of 12 rows. Determine if there are enough seats for a group of 500 people to attend the concert. Again, I notice this is another arithmetic one. I meant to give you a geometric one, but you notice it's just going up 2 every time. See, D equals 32 minus 30. See, it's going up 2 every time. So it says this pattern continues for a total of 12 rows. Okay, so 12 rows, it follows this pattern. We want to determine if in all of these 12 rows, are there enough for 500 people to go? So we're going to have to take the sum of all the rows, first through the 12th row of this sequence, to see if there's enough seats for 500 people. So let's see what the equation is. It's A sub n equals A sub 1, 30, plus n minus 1 times D, 2. So that is 30 plus 2n minus 2. So that's 2n plus 28. So I'm going to plug in here 2x plus 28, and I'm going to go type it into my calculator. Here we go. Alpha window number 2. We're going to do all the rows from the first all the way through the 12th row for the equation 2x plus 28. And that will equal 492 chairs. So here's the question. If there are 492 chairs, are there enough for 500 people to sit? Nope. You got 8 chairs, too short. So there you have it. That's the review. It's so much like the test. It's not even funny. I hope that you study this. We might have a couple minutes at the beginning of class to ask some questions, but this should be a pretty good review because we've covered all this stuff. So study it and be ready for your test tomorrow. Have a great day.